We're going to start off by looking at polynomials, or continuing with polynomials, but this time we're going to do some of the basic operations on them. That is, we're going to add, subtract, multiply. We'll get to division a little bit later, but we already know how to do most of these things, but I'll just have a reminder and a shortening or two different ways of looking at some of these things. Because our polynomials are algebraic expressions, we have already added many polynomials before, right? So if I had in order to add polynomials, let's start again. So to add polynomials, all we're going to do is add like terms, something that we've done before. Add like terms. And we know what a like term is. Like terms, they have the same variable to the same power, right? And so forth. Okay, if we can look at some examples and so on. So examples, example 1, if we start off with, say, x to the 4th minus 6x cubed minus 2x plus 1, and I wish to add another cubic, x cubed minus 2x squared minus 3x minus 5. So I have two polynomials here, one to degree 4 and the other is degree 3. I'm adding them together. Let's get rid of the brackets. We would simply have our x to the 4th, x to the 3rd, 2x plus 1, x cubed, 2x squared minus 3x minus 5. We could rearrange, or it might be easier yet if we just identify what the like terms are. So for example, all the cubes are here, or the only other like terms are the terms in x's, or the terms, the constant terms, right? So all I will do is just mentally put them together, and we would have, writing in descending order, x to the 4th, combining my x cubes, no problem, negative 6 plus 1 is negative 5x cubed. When we are looking further, 4th power, 3rd power, I'm going down to 2nd power. So sometimes what you might want to do is figure out or look carefully to see, whoops, what's going on here? Sorry, my pen, here we go. All right. So if we look carefully, we have gotten these terms already, although they're a bit compacted. I then look for the next degree term. So 4, 3, 2, I'd have minus 2x squared. So I've used that up. I now have degree 1 terms to deal with. I see in green here my negative 2x and my negative 3x. So combining them, I end up with minus 5x. So here we go, those two are used up. And then finally the constant terms, I end up with minus 4, right? So ensure that in combining, you have accounted for every single term that was there. Now there's a second way of doing this addition. So just as we could, from an arithmetic point of view, right? So if we went back to arithmetic and I gave you 17 plus 25, you should be able to do it in the horizontal form, which is what we just did up there. 5 and 7 is 12, carry 1, 2 and 1, 3, and 1, 4. But likewise, I could also have asked you, or you could have put it in this vertical form and then done your addition. 2 here, carry the 1, and you end up with the same answer. So we're going to look at adding and subtracting polynomials in both our horizontal and vertical fashion. So let's start. If I'm doing a vertical addition, it is important to align all like terms vertically. So starting out, I have x to the fourth minus 6x cubed. So I'm looking at descending order. There is nothing for x squared, so I'm going to leave it blank. And then, so I leave a space essentially. Right, so I leave a space for my x squared term, but it's not there. So now the next one, I will go and I will have my addition sign. Here is x cubed. So I'm writing it under each. The space that was left is good that I have this space, or else I would have had everything bunched up. And now I'm simply going to add. And in doing this, you can just, since all the like terms are aligned, I will simply just find the sum of each of the vertical components. So particularly if I'm starting here, I just find what is that sum, what is the sum of the next parts, etc. Alright, and it's doesn't matter if you start from the right hand side or the left hand side, you are simply combining like terms. So x to the fourth minus 6 plus 1 is minus 5x cubed, right? Do note that this sign here, let's put it in a different color, this one is a positive. And we have minus 2x squared minus 5x and minus 4. I want you to get used to both styles, that is adding in a horizontal line and adding vertically. So because we will be using that vertical addition and subtraction as we go on. Alright, let's just try one with more items that are being added vertically. So we could give you, say, 3x squared, 2x plus minus sign, minus 7, and let's say 4x plus 3. What else do I want? 4x cubed, 7x squared, minus 6. So if I have all of these and I'm saying we want to add them, then again I combine all the cubes together, all the squares, and so forth, all the linear terms, etc. Linear terms just mean x to the first power. And so what do I get? I end up with 4x cubed, 10x squared, 6x, 2 and 4 is 6. Watch the sign, negative 7 plus 3 minus 6. So I end up with negative 10. Alright? Okay. Alright, let's do the same now for subtraction. Alright, what exactly is subtraction? When to subtract your polynomial, subtract. So to subtract polynomials, we can think of it as usual subtraction, or add the inverse, the additive inverse. Also called opposite of the polynomial. That is being subtracted. Right, so let's start even again with the one that I had, but this time we'll take a subtraction. X to the fourth minus 6x cubed minus 2x plus 1. If I am subtracting x cubed minus 2x squared minus 3x minus 5. Then what we're saying with the addition of the inverse, if I even brought this back, let's bring back the first part. Recall that to find the additive inverse, it is really the negative. So if I change this to a positive sign, I'm really just distributing that negative throughout. Every single term would be distributed. And we would have negative x cubed. The signs would change. Of course, we don't slow down and write it that way. We would have just gotten rid of all the brackets. But basically, this was the definition of subtraction, that in order to subtract, you add the inverse of the part or the term or terms that is being subtracted. And of course, getting rid of the brackets, now we end up with x to the fourth. I could rearrange them. X cubed minus x, that my plus 2x squared. So I have accounted for these parts. So if you may want to look and ensure that you have all the parts there so far. Minus 2x plus 3x. So those two are accounted for. 1 and 5. Combine like terms. Oops. And here we go. Alright, so this didn't have a like term. Alright, so we'll just bring down x to the fourth minus 7x cubed, 2x squared plus x plus 6. Alright, let's look at subtracting these polynomials in a vertical fashion. And we're really going to look at them in two ways. One way we can do a mental method, and then the other I'm actually going to show all the steps. So let's say that we were given, let's give it out in a subtract, what do I want? Subtract 5x cubed minus 3x, minus x to the fourth from, right now I'm really testing you if you remember your grammar in terms of converting from a verbal statement. Alright, so let's put a little bit more into this. We have these two polynomials, which I want to subtract one from the other. They're not in the, they're not aligned or they're not ordered. So one of the things that we may want to do is we want to order them and we want to put them one on the other. So when we see the word subtract something from, right? So if I have subtract A from B, recall what this means, that the order is changed when you see the terms. A from B, so it becomes B minus A. The order that we see things in, it is changed around. This is different than if I said A minus B would have just given you the same ordering, right? So be aware that when you're dealing with a subtraction and it's a verbal problem, you may have to think a little bit or so. Alright, so given this polynomial, I want to set it up, and what it means, I will have to write 3x squared or so on. Let's order it. So the highest terms would be negative x to the fourth minus, I leave a space for the cube, and minus x plus 7. So here's the first part. I want to subtract from that 5x cubed, x to the fourth, etc. So here's the second polynomial, x to the fourth minus 3x and 5x cubed. You can also notice how I did that I just read from left to right and then went ahead. Alright, if I want to subtract, let's look at it where we actually show what's happening. Let me scurry over a bit here. So I'm subtracting. Either you can show what is happening, that is, I would start out negative x to the fourth minus 3x squared minus x plus 7. The minus sign that I have here is distributed, so I would end up, and this is why we say that subtracting polynomials, it's the same as adding the inverse of a polynomial that is being subtracted. So negative of negative x to the fourth would be positive x to the fourth minus 5x cubed. I'm changing all the signs as I would. Okay. And that's because it was subtraction. And now I simply add them together. We get nothing here, minus 5x cubed minus 3x squared plus 2x plus 7. Right? The alternate way of doing this is to not have a separate or not writing it over, but we can show the sign change, and since I have a different color or have several color pens, I can say that the sign changes here will be what I'm showing in purple. And what we are now doing is we're saying, say for the first term, negative, this first part, negative x to the fourth plus x to the fourth. I'm using the purple, my sign changes that are shown. So I get nothing. I get 0x to the fourth there. The second part would just simply be minus 5x cubed. Nothing is being subtracted from the negative 3x squared. Minus x plus, so again grouping these together, minus x plus 3x would give me a positive 2x, and then bringing that 7. Right? So as we go through, typically throughout this video I will probably show the sign changes, but some of you are fine in doing it mentally, and as we go on, particularly when we start learning about division of polynomials, you will be able to do this without showing me the sign change and just complete the mental method. Sorry. And do it mentally where everything is present. Let's do another one where, okay, so let's again write up something, and I want to subtract. So if I'm given this 2x cubed minus 5x squared plus 3x minus 2 and 5x cubed plus 2x squared minus 4x plus 9. And if I say to you that I want to subtract the lower line, the lower polynomial from the one above it, then let's just look at the sign changes that I would have. This would really be a minus, minus, this is a plus, and this is a minus in front of the 9. Combining like terms, all the cubes, all the squares, all the x's, and all the constants, I get 2 minus 5 is negative 3x cubed. Minus 5 minus 2 would be minus 7x squared. 3 plus 3 is positive 7x and minus 11. Okay. So that really is the way that we do the simple addition and subtraction. Again, you have seen them. You typically have dealt with adding and subtracting in a horizontal fashion using your brackets and combining like terms as you went through. Okay. All right, let's move on to multiplication of polynomials. All right, we have looked at some of these already, where we are multiplying monomials, and just want you to remember that when we are doing this, we multiply the the numbers together and the variables together. And in doing that, we have 3 times -2 and x squared times x to the 5th. Recall that what we're doing is we get -6, the usual multiplication of numbers, and the powers add from our rules of indices or rules of exponents, so x to the 7. At this stage, I'd expect that you can move from the very first, from the question directly to the answers. So as we go on and we are multiplying polynomials, let's start out with, say, a monomial, and it's multiplying this binomial. It's the same principle, right? Each term, we're just using that distributive property that we've spoken about already, and each item inside the bracket is multiplied by what's outside. And in this particular case, we end up with -5 times 12 is -60, x times x is x squared. Watch your signs as you multiply. Negative distributes, and we end up with -45x. All right. Again, that should be quite familiar to you. And let's just try one more with a monomial on multiplying something else. All right. So let's do it a bit longer this time, or longer expression. And let's see, make it pretty easy for you. That's a 7. All right, let's make it to the 5th. And we will have -3x to the 4th. Right, so again we have a monomial multiplying a polynomial, so each item will be multiplied by that monomial, which is on the outside. So it's an extension of the distributive property, with this time having more than one term, more than 2 terms inside a bracket. And so our final answer will be -33. Watch the signs. The coefficient positive times negative is negative. X to the 5 plus 4 is 9. 132. X to the 8th, and -22 x to the 6th plus 33 x to the 5th. All right, so that's rather simple. All right, let's move on, but we're going to look at multiplying maybe a binomial and another binomial or more. All right. So just in general, multiplying polynomials. So we can use this distributive property a bit, and let's say that we had say x minus 12 times x squared plus 4x minus 3. All right. In essence, I can use the distributive property, and I can say that, or make this familiar to, say x minus 12 times a. What would I do with that a on the outside? Each item would be multiplied by a. So using that distributive property, I'll get xa minus 12a. It's the same thing that I'm going to do, but this time imagining that this x squared minus 4x term is my a. It's not opened up yet. And so what I get using the distributive property is that x will multiply the whole of that term minus 12 will multiply that highlighted term. Right? What exactly was my highlighted term? Let's fill it in. And x squared plus 4x minus 3. So essentially we are breaking up one of the factors. We're breaking it up and we are multiplying by the x's and everything behind it, and we get the 12 minus 12 rather, and we are multiplying everything by that minus 12. Seems a little bit okay. All right, so let's see what we get. The final result, distribute the x, and we have x cubed plus 4x squared minus 3x. Distribute the minus 12, and you get negative 12x squared minus 48x plus 36. So essentially we have to combine like terms. Again, identify your like terms. Here they are, and we now combine them. This is in a horizontal fashion. I'll write my final answer in descending order. So minus 8x squared and minus 51x plus 36. Again, remember to watch the coefficients so that you get the proper signs. All right. It doesn't matter if it is a binomial times a trinomial or two trinomials that we are multiplying, the same principle applies. So if we should take, so it'll be a bit long, but if we should take, say, 4x squared minus 5x plus 8 and 2x squared 7x plus 4. Alright, same principle. What I'm doing is I'm taking 4x squared times the second bracket, 5x times that whole thing, and 8 times the whole thing. Alright, so let's just write back what we had in that second bracket. 2x squared 7x plus 4. 2x squared minus 7x plus 4, and here we go again. So it doesn't matter how many times I have it. Alright, what do we get? Now I'm going to do this a little bit differently. I'm going to find the first product here, and let's see what we get. So you'll see why I do this in a bit. So simplifying 8x to the 4th, and I have minus 28x cubed and 16x squared. For me, it's easier just to actually incorporate some of the ideas that we had before of the horizontal and vertical. It's fine that I have this all horizontal, but I can make my process, for me, I can make my process more efficient. You decide upon how it works for you. So I'm multiplying out by the negative 5x. I have negative 10x cubed plus 7 5s is 35x squared minus 20x. And now let me multiply by the 8. 8 2s is 16x squared. So I'll just write that next. And minus 56x. 4 times 8 would be 32. So I have these three lines, and I really am just adding them together. For me, it's easier, and I can see it seems a bit more organized for me to do it. But again, there's no problem in you writing it out in a horizontal line. So 38x to the 3rd. Adding these, we have 3267x squared. 76x and 32. Do check my calculation. I believe that it is correct, but I just am making these up as I go along, so I do want you to check. All right. Let's do another one. It doesn't it doesn't always happen. We can have different degrees even though it's a binomial. We could have say 3x squared minus 2 and x minus 4, let's say. Right, if we are multiplying this again using that FOIL method, let's put it together. 3x squared times, let me write this out just to make sure that you see what's happening. That's the product of the first terms. Remember, watch your signs. So the outer is really 3x squared times negative 4. Next one was minus 2 times x. And the last term was really negative 2 times negative 4. Alright, there's a question as to where am I getting all these positives and negatives. Let's just look back again at the alternate way. Remember, terms are separated by a plus sign. So an alternate way of writing my expressions here would be to say that I had 3x plus negative 2 or x plus negative 4. Hence, in doing or using the FOIL, you can see clearly what I'm picking up. Now, we oftentimes don't have the time, or we have gotten so used to this that we don't really look at the terms individually as plus negative 2. So we will combine, we will look and use these or recognize that the minus 2 is what is going to be multiplied. But the meaning comes from what we have shown below in this colored fashion down here. Alright, simplifying, we ended up with 3x cubed minus 12x squared minus 2x and plus 8. You will notice that there are times when I have like terms, right? And those times that I have like terms, the degree of the binomials would probably be on the same level, but here when I have the binomials in the second or this last problem that I just put up, the degree of the binomials were quite different, and so we ended up with 4 distinct terms rather than something to combine and show. Alright, now you've been doing that for a while, so let's just turn this about and try to look at what it is to multiply in a vertical form. So I'll remind you when you were doing, say, your numbers and so on, regular numbers, you would have something like this, 27 by 13. You would do 3 times 7, so you multiply by 3 first, and you got 3 times 7, 21, you carried a 2, 3, 2, 6, 7, 8. Later, you would multiply by the next number up, or the next place, which was the 1. You'd write a 0 there, then 7 and 2, and finally you would add what the results that you had gotten, and you'd end up with 351. Alright, now in the same way, I am going to look at multiplying these polynomials. So let's look at, say, x squared minus 3x plus 2, and I'm multiplying it by x minus 5. So we're multiplying. What I want to do first is multiply throughout, let's say by minus 5. So this is what we call a partial product. Right, so it's a partial product by minus 5. It's running out of room here. Okay, so let's fit it in by. Pretty much as we had done a partial product by the 3 that was here. It's not a full answer. Alright, so what do we get? Negative 5 times each item. Whether you start from the end, like from negative 2, or you started from the squared term, it really doesn't matter, because you're just going to line them up in the order or like powers under each other in that vertical form. So I could line up, I could start out minus 5x squared plus 15x and minus 10. Okay? Or if I did minus 5 times 2, negative 10, you put them in at each stage. The next step would be that partial product by the x, the next term, which is this. Right? Okay, and in doing that, I would have x times x squared is x cubed, so I got to move out a little bit further, minus 3x squared and plus 2x. I now take the sum of these two partial products, and in taking the sum, I ended up with x cubed minus 8x squared plus 17x minus 10. So this is my answer. Alright, if you want to check that, let's see. If I want to check that, I could, let's write it this way, x squared minus 3x plus 2. Let's look at it in the horizontal fashion. In the horizontal fashion, I'm doing it the same way. And we have in here, let's say x squared, 3x plus 2, x squared minus, rather, 3x plus 2. Alright, and in expanding, I ended up with exactly the same thing as I have in the lines above that corresponded to these partial products, right? So this here is exactly that. And when we go to the next part, go to the next part and I expand. So if I multiply this, it doesn't matter that the monomial, the negative 5, is on the right hand side. It's the same thing. Everything inside is multiplied. So I would get negative 5x squared plus 15x and minus 10. I only wrote negative plus negative 5 because I've written the plus sign already. Now combine in like terms. I have my x cubed, and now we have here, these are our squared terms, or x's needs to be combined, and it's exactly the same as I had above. So we end up with the same result, minus 8x squared and plus 17x minus 10. Okay. It doesn't matter if we should have multiple variables such as, x and y, etc., etc. So let's look at one or two like this and then go from here. Let's see, what number did I reach? All right. So let's again do a vertical form. So this was number 1. Okay. Number 2. So let's practice the vertical form since that part might be a little bit new to you. And this time, well, let's even do, say 3x squared y minus 5xy squared. I want to multiply that by some 2x y minus 5. Alright, you don't need to line up these as like terms. They had nothing in common, but the idea is to find those partial products. And in this case, one partial set is by negative 2x, by negative 5, and the other by 2xy. Alright, so let's do the minus 5 part first. And this time I'm going to, so let's do that. And what do I end up with? If I did minus 5 times minus 5, I could do positive 25 xy squared. Negative 5 times the rest, the other term, would be minus 15 x squared y. It doesn't matter if I start with my multiplication from left or right. Just that as I go, I should try to line things up. Alright, so I probably did this one very badly, because I'm seeing that nothing lines up now. When I multiply by 2xy, I get negative 10x squared y cubed, which is something different. Negative 10x squared y cubed. And this is why you need to probably put things over. But I'll use my margins. And I end up now with 6x to the third y squared. Right? So notice that the second line is moved over as far enough so that we won't have unlike terms in the same vertical column. Right? And yes, it led to me being outside of my margins, but never mind. We just continue working. So in adding, my final answer is 6x cubed y squared, 10x squared y cubed, minus 15x squared y, and 25xy squared. So the lesson, I guess, is when we're doing some of these in a vertical fashion, you might need to center your work on your page. All right. Any questions? All right, so we need to move this line, move far enough so that we do not have unlike terms beneath each other or under each other. Okay, let's try another. And right, if I gave you this, simplify. So 2m to the fourth, 3m cubed, and so 2, 3, 4, and let's say 5, and we're going to multiply this by, say, 1, 2, 3, 2 minus 3m. Alright. Okay, we have these polynomials. While the first one I have lined it up in a descending order. The second one, this is not. This is an ascending order. When we're multiplying, it is useful to keep them in the same order, whether totally ascending or totally descending. So we will first reorder, and I'm making the choice since the majority of the times we will be using descending order anyway, unless otherwise told. then I will write each of these in the descending order, and I want to solve this. I want to simplify this using vertical multiplication. Alright, so starting out 2m to the 4th minus 3m cubed, and I did start further over. Alright, let's start even further over so that I don't crash into my margin. 2m to the 4th, 3m cubed. Notice that there's a term missing, or a power that's missing. 4, 3, I might end up with a square, so I'm going to leave that blank. Or later on, if you wish, you can put in a 0 in there. You see why, particularly when we go on to division, this will become a bit more important there. So if you want to put a 0m squared, it's up to you, but it's optional. And now let's continue. We have our 4m minus 5. I'm multiplying this, and let me line this up. M squared minus 3m plus 2. Okay. So this time we're going to have 3 rows that we're going to add, since there are 3 terms in that polynomial that I'm multiplying by. So this part is sometimes just called either a placeholder or a spacer. Right. And this is essentially just needed because I am trying to write all my like terms underneath each other. Alright, so starting with, let's say we start with positive 2 here. So let's start with this. What do I get? So I color code that, but I'm doing everything in the black ink. Alright, so 2 doesn't matter. Some of you like to start from the end. Minus 10, then we have 8m, and 2 times that would be 0m squared still. 2 times negative 3, negative 6m cubed, and 4m to the 4th. Next, we're going to do our 3m. Watch the signs. Alright, so negative 3 times negative 5 would be positive 15. Negative 3 times positive 4 would be negative 12 m squared. Next term would be 0m cubed. And we continue. 9m to the 4th, and then minus 12m to the 5th. Right? Okay, any questions so far? If not, we're moving along. We're now just multiplying by m squared, and in doing that we see that the highest power will be m to the 6th. Some of you are getting annoyed with me starting from the left when there's probably no need to. Alright, so let's go 2m to the 6th minus 3m to the 5th plus 0m 4th and 4m cubed minus 5m squared. Right, so I'm simply multiplying each term by the respective term in the trinomial. So m squared is the last line, minus 3m is the partial product of the first, and then I multiply the partial product with 2, and now we have these 3 lines. Let's add the terms. We end up with 2m to the 6th, 15m, so 15m to the 5th, 9 and 4 is 13, minus 2m cubed, minus 17m squared, 23m minus 10. Right? And that's our final answer.